Welcome to another tutorial of ProfLearn YouTube channel. In this particular live, I want us to have a transition, and also I give you an update what to expect in further pure math. If you are going to do FP1, that is further pure math called WFM01/01, then we're going to have a discussion on the kind of topic that you really expect to look at and what you are expected to know in that area. As you are preparing for your further math exams, I would like to bring to your attention that you can be able to join our Patreon page so that you can be able to access all the materials, all the PDF, and you can be able to get more updates as we continue with lessons in ProfLearn YouTube channel. We are going to have a discussion on the topic matrices and what you really expect to know in that topic and what is expected of you to learn. Educare International is a platform that also help you to access your university of choice. I've not been paid to promote this, but I find this as a good organization that can enable you to really get to know what are requirements for different universities in different courses. So as far as this particular topic for further pure math is concerned, you need to understand different types of matrices. And in this case, you need to know we have a square matrix, we have rectangular matrices, we have a square matrix is a type of matrix where the number of rows is equal to the number of columns. For instance, 2 by 2 matrix is a square matrix of order 2. And also we can talk of 3 by 3 is a matrix with order 3. So which means that you can be able to identify that. You need also to remember we have something we call a null matrix. A null matrix is a type of matrix where all the elements you have in that particular matrix are all 0. Then we have another type of matrix which is called a singular matrix, whereby we're going to understand that later, that a singular matrix is a type of matrix where the determinant of that particular matrix is 0. So if you are told to write a 4 by 3 matrix, you need to understand that this means that 4 is the number of rows, and when you are moving across like that horizontally, those are rows, and 3 is the number of columns. Yeah. Then if you are supposed to add matrices, you need to remember that you are adding corresponding elements. For instance, if you are adding matrix A plus 2B, first you need to multiply 2 into all the elements, because this is a scalar multiplier to matrix B. And then that will mean that you're going to get 2 times 4 will give you 8, 2 times 6 will give you 12, 2 times -1 will give you -2, 2 times 2 will give you 4. Then now we can proceed and go ahead to add these matrices, because we are going to add 2 plus 8, because this is in the first row, first column, then you add to the first row, first column. Yeah, so this is going to be 2 plus 8 is going to give us what? That is going to give us something equivalent to 10. 4 plus 12 will give us 16. 6 plus -2 will give us positive 4. 3 plus 4 is going to give us 7. So that is how you get to add matrices. But if you are doing multiplication of matrices, you need to multiply row by column. So first we shall talk about scalar multiplication. Scalar multiplication means you are having just a single number outside the bracket which is going to be multiplied into that particular matrix. So which means that that scalar multiplier is going to be multiplied to all the terms which are inside that matrix. Right, so that is what you consider whenever you are asked about multiplication of matrices. Now let's check a scenario whereby you are going to multiply different matrices, and in this case you are multiplying matrices together. What do you do when you are supposed to multiply matrices together? How do you go about it? Now, the first thing that we need to realize that whenever you are trying to multiply matrices together, we're going to multiply row by column. So in this case, if we want to find this element at this point, to be first 1 times minus 3 plus negative 2 times 2. Then if we want to find the element down here, will be 3 times minus 3 plus 4 times 2. Then if you add that, you're going to get 7, negative 1. Number of rows must be equal, number of elements in rows must be equal to the number of elements in the column for you to perform what we call multiplication of matrices. So that means that if two matrices have the same number of elements in the row and the number of elements in the column, it will mean that those two matrices are compatible and they can be multiplied. So that is, you need to understand how to multiply matrices. And the next part now you need to understand also is determination or calculation of a determinant. This, if you have a 2 by 2 matrix like this one here, it has two rows and 2 columns. It means that for you to find the determinant is going to be det A, because the matrix is A, so determinant is denoted as det A, or it's denoted as modulus of A, or it can be given as triangle of A. Then in that way you can be able to say A times D minus B times C, which is going to be our values that we shall have at this given point. So this becomes the formula you shall be using in order to work out matrices determinant. So if the determinant of a matrix is 0, then we are going to say that type of matrix is known as, or is known as what? Is defined as, is referred to as a type of matrix which is called a singular matrix. So a singular matrix is a matrix whose determinant is 0, and then we're going to see later that this type of matrix has no inverse. We are going to see how to go about that. Then we are given a matrix like A, where the element is 4p plus 2 negative 1 3 minus p, is a singular matrix. So if you are told is a singular matrix, it means that that matrix has a determinant equals to 0. So it means that you're going to say 4 times into 3 minus p minus p plus 2 times negative 1. When you subtract the 2, you are going to equate the determinant equals to 0, because already here you are told that the matrix is singular. This is a singular matrix. Then if you work it out, you are going to have an equation which you are going to solve, and that equation is negative 3p plus 14 is equals to 0. What does that mean? That means that p is equals to 14 over 3, and that becomes what? Our value of p. If you are new to ProfLearn YouTube channel and you're going to do the May-June exams of 2026, you're going to sit for the exam January 2026, consider subscribing so that when I'll be uploading more tutorials on this series, you'll be notified. So we need to move ahead, we need to continue and proceed and get to see what else are you expected to do, especially when you are given question to do with matrices. Now, like this example is an example that is going to lead you to the formation of a quadratic equation. So you can see here you're given 3x 7, 4x plus 1, 2 minus x. So you're going to multiply this element and this element minus the product of this element and this element, but you are going to say, because they are saying what the range of values of x, so that the discriminant e of m is positive. When do we have a number positive? Is when the number is greater than 0. So which means you are going to say to find the discriminant, and you say det or discriminant of m greater than 0, so that this number is going to be positive. Then we end up having a quadratic inequality, which we are going first to equate that inequality to 0, so that we can be able to solve it and get we get what we call the critical points. And once we have the critical points, we'll be in a position of working out those critical points and use them in order to work out the range of values for which this is going to be positive, and that is going to be x is greater than -7 but less than -1/3 as the final answer in that case. So basically that is what you are expected to do. And now let me just change the gear so that I can take you straight to another area. This is a kind of exam question that has been asked in previous years, so that you can be able to see exactly what you are supposed to do here, whereby we are told that given a matrix A is equals to this, where k is a constant, find the value of k for which A is a singular matrix. And in this case, you are going to find the discriminant. You equate this discriminant to 0 because it's a singular what? Matrix. Yeah. So in that solution, we're going to say det of this matrix A is going to be equals to 0, and determinant will be 3k times 6 minus 2 times 4 into 4k minus 1, and that is going to lead to an equation which is 10k is equals to -2, and which means if we solve this particular equation, we are going to get nothing other than k equal to -0.2 in this case. Given A is a non-singular, determinant, a non-singular matrix. Given A is non-singular, which means the discriminant is equal to a given number. It's not singular, it's non-singular. So which means the discriminant is not equal to 0 when they are saying that is what? Non-singular. So in that case, we're going to take this expression that we have gotten here, 10 plus 2, 10 what? 10k plus 2, we shall say, because equation of inverse of a matrix is 1 over determinant into the bracket. You are going to switch the values or the elements in the leading matrix. If you are having like this one, this 6 will go there and the 3k will come down here. So you can see 6, I took it there, 3k I switched it there, so that we have 6 3k. Then for the other diagonal, we are going to switch the signs only. Then we multiply this determinant in, and this is going to reduce to this particular expression that we are having at this given point. Now moving to the question 2, matrix M is defined by this kind of element or matrix. We are supposed to determine the values of k for which M is singular. So which means you are going to work out the discriminant, and that's going to be k into bracket k plus 5 minus -2 times -3. Then we equate to 0, because in that case the discriminant is what? Equals to 0, because we are told is singular. And then it means that if we solve that, we're going to get k is equals to 1 or k is equals to -6. Those are the values of k at that given point. Given that M is a non-singular matrix, find M, the inverse of that. You are just going to take this expression without equating it to 0. Yeah, because we equated here to 0 because this is a singular matrix. But now, since it's a non-singular matrix, we are going to go ahead and we should not equate this to 0. We shall say 1 over k squared plus 5 minus 6 into bracket. Now we are going to switch. K will go here, k plus 5 will go down, and then we shall switch the sign of these numbers. This was -3, it becomes positive, and if it was -2, it becomes +2. And if we can leave our question there at room temperature and pressure, so that we can earn the marks in that particular question. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. So in ProfLearn YouTube channel, I do maths and physics, and so that you can be able to prepare for your exam. Also, if you join our Patreon page, you'll be able to access the PDF of all these my notes I'm having here, so that you can be able to download them and you revise them at your own free time. As you are also preparing for your exam, you'll be able to save more time and look into more past paper revisions. So moving on, also this is a question on that was tested in an exam. You are told, given that this that A is this matrix and B is this particular matrix, where K is a non-singular matrix, in an zero constant, where K is a non-zero constant, this K that we are having here. And then you are supposed to determine the matrix AB. So which means first you have to multiply the two matrices. If you are told matrix AB, you stick to the order of multiplication in matrices. If you switch them off, it means you are going to get a wrong answer in that case. So you have to ensure you are following instructions whenever you are given a question on matrices multiplication. So in this case here, we are going to say we are sorted, we are okay. Then we shall now expand, and if you expand or multiply these two matrices together, of course you need to remember that for you to get this element at this position, it will be 2 times 1 plus negative 1 times 0 plus 3 times 2k, row times column. Then that will give you the answer for this. For you to get this element here, it will be 2 times k plus negative 1 times negative 3 plus 3 times 2. You get that. 3 times negative 1, negative 2 times 1 plus 3 times 0 plus 0 times 2k will give you this element. And lastly, negative 2 times k plus 3 times negative 3. You can see it here, 0 times 2, well seated at this point. If you work it out and simplify these terms that you have, you are going to get your answer 6k plus 2 negative 2. Then we shall have 2k plus 9 negative 2k minus 9. Determine the value of k for which the determinant AB is equals to 0. Now sometimes they'll tell you find the value of k given that AB is a singular matrix. So same language, same conversation, that you are going to find the determinant of this particular matrix and then you equate it to 0. Then you solve it, you will get two values, k equals to 0 or k is equals to negative 9 over 2. But you are going to cancel, you are not going to take k as one of the solution, because in this particular question we are told that there's some information that was given prior, and you are told that where k is a non-zero constant. That information was mentioned here. It was not mentioned there for pleasure or for any reason, but it was meant there for you to be able to work it out. So we shall be working more on that. Now the next part we are going to look at is the transformation of matrices, because matrices can be used to transform different kind of geometric shapes. So we need to understand in A-level physics, A-level math, you need to understand linear transformation. What do we mean by linear transformation, and how you can be able to identify that a transformation is linear. There are key areas that you need to remember. That if a transformation is linear, it means it can be expressed in the form, then it can be expressed in the form ax plus by. If you get ax squared, or you have a over x, then that kind of transformation is not a linear transformation. And also a linear transformation can always maps the origin to the origin, or the origin is an invariant point. So it can be expressed in this particular form, and also the origin is mapped to the origin. So you can see like this one, this is not a linear matrix because it cannot map. You can see this one, if we have a point 0 0, it will be 2 times 0, which will be 0, 0 plus 1. So 0 0 is mapped to 0 1. Then this is not a linear, this is not a linear transformation. So you need to take note that if T is a transformation that maps x y into ax plus by cx plus dx, then this is a linear matrix. Then the matrix of T, this transformation T, can be written as A, B, C, D. So that if you take A, B, C, D times x, y, it will take you to this particular value that we have here. Write the matrix that represent this transformation. This is going to be matrix 1 because x is 1, 2, 3, 0, like that. And this one is 0, negative 2, 3, 1, and we have it like that. So basically that is just a summary of what you expect. And now we can just look at another area. And this area that we have here, we have reflection, different transformation, right? So under different transformation in A level further math, you are going to learn about reflection on the y-axis, reflection on the x-axis, and then you need to understand, you need to be able to come up with the matrix of that particular transformation. So for you to come up with the matrix of a transformation, you can be able to use a unit square. Then you use the I as the object and j as the object, times a particular matrix A, B, C will give you the image. For instance, if this is a reflection, this point will be reflected on the other side and the image of J will remain where it is. So the transformation becomes the image of I and the image of J. Image of I, negative 1, 0, and the image of J, which is 0, 1. You will get your answer like that. So reflection on the x-axis is 1, 0, or 0, negative 1, but reflection on the y-axis, negative 1, 0, 0, 1. Then the invariant line for a reflection on the x-axis is x is equals to 0, y equals to 0, or y equals to k. Those are the invariant line. So which means that that line, if it's transformed, it remains the same point, it does not change. And invariant point on a transformation are those points upon undergoing that particular transformation, they are not affected by the transformation, they remain the same point. Yeah, for instance, if we are talking about a reflection on the y-axis, the point on the line of reflection, for instance, this y-axis, any point on the invariant line remains that particular point after the reflection. Now, when we are talking about rotation, remember, it can be defined in terms of the angle of rotation, and also it can be defined about which origin are you, which point are you rotating it. So in general, the matrix of rotation of angle theta about the origin is going to be cos theta, negative sine theta, cos theta. For instance, if we were having a rotation in anti-clockwise direction about the origin 0, 0, that's going to be sine 180, negative sine 80, sine 180, cos 180. If you put that in your calculator, you are going to get answer surprisingly becoming, the answer becoming 9. For instance, if we are saying, if we are looking at this and we are saying that we want to find cos 180, so we are going to say this is cos 180 here. So if you find cos 180, basically it's going to translate to negative 1, isn't it? Negative sine 180 will become 0. Sine 180 will become also 0. Cos 180 is going to become what? Negative 1. So basically you are going to get that this particular matrix under the rotation of 180 about 0, 0, anti-clockwise is going to be negative 1, 0, 0, negative 1. And you need to understand at that given point that 0, 0 is a point which is an invariant point. Yeah, so this point that is here is going to remain there even after the rotation. And then we have any line that passes through the origin is an invariant line, so that line upon rotation it remain at that particular point. So up to that point we can say that is going to be the introduction. That will be our introduction to further pure math. So more of the tutorials and more of other units math will be coming, and also physics. So as you are resting in your holiday before resuming back to school in September, remember that ProfLearn will take care of the concept that you're going to be doing. So don't move away from ProfLearn. Just share some of these particular tutorials, and also remember to join our Patreon page in order for you to be able to download this particular PDF that I'm having here. See you in the next tutorial. See you guys.